network called Filecoin. I'm also going to be, yikes. So this, wow. I think my screen got it. Okay. Sorry about the technical difficulties. It's a new laptop. So I'm going to be talking about decentralized storage networks and Filecoin and Estuary. And I think for a lot of people, they don't have the whole context of how we came to where we are today. We see a lot of stuff in marketing, and we see a lot of stuff in the current kind of like prog space that kind of show like the output of what we're doing, but there is an original thesis. There was original goal for all of this. And so I'm going to cover what makes a centralized storage network, what composes it, and also talk about what we did with Filecoin that makes it unique, and what we're doing with this new product called Estuary, which is a platform for making it easier to store data. And during this time, if you have any questions, feel free to interrupt me, to throw like controversial stuff at me. It's all good. I'm ready for any question that you may have. And so if you don't like care about what we're talking about today, just know that if you know what Bored Ape is, that line, when you look at the metadata, the IPFS:// that's what we work on at Protocol Labs, and so much more. We provide a lot of research for everything. In fact, I feel kind of guilty coming in today representing all of Protocol Labs because so many engineers have put in so much work, and researchers, to make it all possible. So shout out to everyone in Lisbon. Right now we have our Protocol Labs Lab Week where most of our team is there. And there are a lot of engineers who kind of worked the last 8 years plus 4 years maybe to kind of make this all happen. So thank you very much for letting me speak at UBC. In 2014, 2017, Juan Benet and a select group of friends kind of announced that we were in the middle of an internet revolution. So what we have today is like 2,500 Web 2 applications, centralized applications that are gradually being kind of on track to be replaced by decentralized stuff. So that kind of means more open database, more code that runs on its own, that's more fault resistant, more stuff that isn't reliant on a central node to govern everything, and kind of replacing monolithic services in those marketplaces that are generally opaque with peer-to-peer algorithmic marketplaces, which is what you're seeing today with different tokens. In 2022, where we are today, we didn't really get to that level of adoption fully. We haven't obviously crossed the chasm yet where we're fully decentralized. And I don't think we ever will be. I think centralized services are still used to support a lot of centralized services, but we're learning a lot from DLTs. We're learning a lot from this technology that we're building. And I want to call out AWS, which is the perceived leader in the space of storage with over 200,000 petabytes. And, you know, they have a kind of a 20-year advantage on us. But today, you know, Filecoin, after 2 years after launch, which is happy anniversary to Filecoin, we're at about 20,000, which is really cool. Like, we're getting there. And I think it shows signs that people can appreciate this technology. And I'll get into more of those details later. And so you can see this graph here. This is from a website called storage.index.io. You can see AWS is kind of leading the way, and Filecoin is at the number that it's at. But over time, we're probably going to make some progress that changes this graph. And so, you know, this will be fun to look back at, you know, 10 years from now, when we're presenting this together today, we might have made some bigger changes. And so, hello, UBC. Thank you for having me. I really appreciate it. I'm honored to be presenting my team's work. Jeremy Johnson invented IPFS. And so representing him and everyone at Protocol Labs is really fun. We're going to talk about how decentralized storage networks were supposed to work. We're going to talk about today where we are with the concept. And so you guys can understand some of the underlying pieces. No one talks about this in marketing today. We talk about generally how you use it, what's the API, but it'd be nice to go into some of the thesis and some of the proofs. Also, we're going to talk about Estuary, which is something that, you know, you might have heard of Web3 storage or NFT storage or a whole bunch of other products, but Estuary is kind of this broader vision that we like to cover. Let's talk about it today. We'll give a short demo so you can see me upload some data, which could be cool, could be boring, whatever, but you'll get to see it happen in real time. And then we'll do a Q&A afterwards where you can ask me anything you like. So centralized storage networks. Let us begin. So in short, you got a whole bunch of nodes in a network, sharing responsibility of storing information. Instead of the centralized model, which is one centralized node, and then a whole bunch of other like kind of opaque nodes that you don't really know what's happening, that's shared in responsibility, but if that central node goes down, everything falls apart. We call that not being fault resistant. And that's bad for you know, if you want to, like, if a country were to censor something that's very valuable, like some knowledge, you know, they can do that because things are centralized. You probably heard this a lot before. So here's kind of a graph of like the centralized kind of network. You cut the root node, everything is dead. In a decentralized network, you can kind of cut individual pieces, but some things will still work in different parts. And distributed is like the coolest. That's like the 2030 plan, where everyone has a copy or replica of that data. And also, fun fact, the replication strategy is the way we get data over to the moon, hypothetically, because you can't send data as fast to the moon as you'd like. And so, you know, decentralized storage networks can be characterized as a network that turns traditional cloud storage APIs and their composition into a kind of algorithmic market. So the code is the law. It adjudicates what actually happens. You interface with any node, you get the same thing. Instead of like having to go through one node that makes its own rules, and there might be some adjudication by law, there might be some open source code that says like, this is how it works. But because they're the only ones who run it, it's not fault resistant. Compared to like if 20 people were to run the same code, you can kind of trust like, okay, we all agree to these things. And consensus is very powerful for inspiring trust from our users. The market component for these blockchains kind of run on with a native token. So this is like a fancy way of saying, you know, this is how like all the ERC20 and all like the token economics you see today with every other chain. So Bitcoin, Ethereum, et cetera, they all have a token that incentivizes the usage, right? And they all have different like crypto economics. And so you might have been exploring different forms of this. You know, they're all very interesting. For us, the idea of a centralized storage network is you can have the aggregation of a whole bunch of independent storage providers. So they all run the same code, but it's likely that they have different varying amounts of storage capacity. And you know, we use consensus algorithms. And so this is talking about DSNs as a whole. There's various ways to guarantee that they're all agreeing to the same underlying rules, right? So there might be like, you know, a data center that has a few petabytes and a data center that has a few terabytes, but are able to work in the same network. And that's kind of like the variable. But then they're all agreeing by some consensus algorithm that they should all be following the same rules and proving that each other are doing the right thing, right? And so these things kind of incentivize storage providers to provide as much storage as possible. So it's a simple math formula. Things don't have to be complicated. More provable storage provided, where everyone agrees that these things were stored, more revenue. This is a great way to onboard people to the network. And the other thing that is nice is that the user, for better or for worse, has control over what they're doing. So if you're responsible for your own encryption, you're responsible for how much replication should exist, and you're responsible for kind of managing your own like ownership rules, we have proof that there's a term called provenance, which would prove what came before the other, who made what. You can kind of prove this out, and it's nice. So fundamentally, for the end user, though, in the world, if we achieve what we want to achieve with DSNs, there should be two methods: putting data and getting data. And I think most people can wrap their heads around this. You can imagine like a protocol as simple as HTTP, where it's very easy to use. It's very simple to send messages across the wire. Storage should be available to everyone. If you believe in DSNs, you just put and get. And I like this definition a lot, because if we achieve this, I think it'll create a lot of benefit to everyone. And so I create this like nifty diagram. This doesn't apply for just Filecoin, but to kind of communicate how simple this is. User puts in data. It's a centralized network with a whole bunch of storage nodes. You don't care who has how much. You're able to find someone who stores it, and a user or client or browser can retrieve it back out. And so that's the goal with DSNs. So what makes up Filecoin? What is Filecoin then? Like, is Filecoin a DSN? The answer is yes. And we have a couple of proofs that make Filecoin more advanced than another DSN that might have been made in a different time. We invested a lot of time into the research to kind of like help create these very, very fault-tolerant proofs, proof of replication, proof of space-time, to help verify that everyone's doing their part in the storage network, which is important because when you start a storage network, you might only have one or two nodes. If you're like a new layer one network, you might have very few, and you might keep it centralized so you can kind of grow it and be careful. We're out in the wild and we have a lot of them. So they all have to agree and have consensus of what's happening on the network. So this requires a really well thought out proof. So proof of replication is cool. To register a sector with the Filecoin network, a sector has to be sealed. The computer, I'll talk about that more later. Computer proof ties to the data itself. after performing the sealing and the time specific data has been sealed by a specific storage provider. And once the proof has been generated, the provider runs a snark on the proof in order to compress it and submit the results to the blockchain. And so like, this is a real big shout out to one of my coworkers, Porsecoin, who invented a zero knowledge proof that would make it a lot faster, reducing the cost around like 10 milliseconds. So consensus around a lot of machines is really hard, but the fact that we are able to kind of invent these proofs make this more possible. Proof of replication is one of them, and proof of space-time is another, where a storage provider must prove they're continuously storing the data they pledge to store. There's two types of challenges involved. So once you store the data, the storage provider has to provide a replica of that data at a specific time when they were asked, and they're given a short deadline. And so what makes our network unique is like you have to put up some collateral, which can be pretty painful, a lot of capital. But this is good because if you put up collateral, everyone can trust that you don't want to lose your money. So you will continue to prove back to us that we've given you the data, or you have the data and you're able to give it back to us. And window post is to prove that data is maintained over time. So it's not enough that they're able to prove once that they have data. We want to make sure over the duration of time that they're storing data for us, they're submitting proofs regularly to prove this, right? And so this makes consensus possible. Not only are we proving that they have parts, but we're proving over time that the data is there. And now we don't even need to, if it all works well, we have a system that we can fully trust that data is being stored to achieve the put and the get that we wanted earlier. And so to make this possible, you can imagine, especially if you're studying computer science or you know about network latency, to do consensus is very expensive, right? So we're doing research, and I think the ZK Snarks talk could take a really long time. Like it could be its own individual talk, but we can prove that some things have happened without revealing the information and requiring no interaction between the prover and verifier, which is absolutely huge. This can reduce the latency of a lot of things. And I can later on, if you guys want to see like a benchmark of this compared to existing things, I actually wrote one on the board over there to explain to Karine earlier. But yeah, it can reduce the time. And so DSNs like Filecoin have this competitive advantage because we spent so much time researching these things. So we are actually achieve consensus at a much faster latency than other networks. And this is something that I don't think is communicated very well, but it's also kind of like leading by example, because I think everyone who wants to build a DSN, we might not be the only DSN just because they're valuable, can learn from us on like how much we've achieved and kind of apply the same methodologies to our own DSNs too. And we're hoping to see that as well. And so some definitions, just in case what I said earlier doesn't really make sense. Clients, like your browser, the user, or any software that pays to store data and retrieve data from a centralized storage network. We use that as a term for the Filecoin network. We have storage providers, and you can guess what they do. They provide data storage to the network. They plug into this consensus system and they respond to the put I mentioned earlier. So you can put data with them, and they prove that they're storing the data. Then we have retrieval providers that provide data to the network and respond to the GET requests. This is in development, but ideally you have people who are working on the side of getting data out, right? Because what's the point of storing data if you can't get any data out? And then there's also a globally available ledger to show the sequence of transactions that are append only, typical DLT that you may see with any other chain, to kind of show the provenance of what's happened transaction-wise. What is also unique about Filecoins, we've created some other terms. So you have the idea of a piece, and these are parts of data that any client is storing on our DSN. You have sectors, which are disk space storage provider has decided to provide to our DSN. Before a piece can be stored, you have to pledge a sector that involves like providing collateral, saying I'm going to have this amount of space available so that people can ask you to store data, and you can say yes. I know it sounds really simple, but to coordinate that is really hard, right? Like you have so many nodes in network to make sure that every storage provider can do this, and also to make sure that they're able to receive that data, etc. Pledge is a commitment to offer a sector. It consists of the size of the pledge sector and the collateral in Filecoin deposited by the storage provider. So these are kind of pieces of our network that kind of tie into the consensus side of it. And so here is the flow for like what a storage provider would do on the Filecoin network. There's the pledge, deposits collateral in Filecoin as a pledge transaction. if the proofs end up failing later, so we talked about two proofs, right? Proof of space-time and proof of replication, the pledge is lost. And this mechanism, I'm actually very proud of it because even though it's very painful right now for storage providers, it does ensure that you're not going to be a bad actor, especially if you're putting up money to store data. It's kind of like a safeguard. Then we have add order. So once the pledge transaction is successful, storage providers can set their price and they can add their order for storage onto the network. So they can say, hey, my name is John. I'm offering, to store gigabytes of data for you at this cost, right? And then a client, which we talked about client earlier, that's to talk about like you're a browser, you're a piece of software on someone's computer. Like, hey, I want to match that order. I have maybe some genomic data for you. I like your price. I'll store my data with you on the network. And so they send their data to the storage provider. And then there's a process of sealing, which is then when you start getting the proof. So like once we store the data, let's prove that that data is stored. Once the data is stored on the network, what's really cool is there's a whole bunch of gossip system, using libp2p and gossip sub like under the hood, which allows everyone to kind of communicate that data is there. And then there's a retrieval process that produces artifacts that are submitted to the Filecoin blockchain and to the requesting client. And so here's a very simple example of retrieval: Filecoin in, data out. I know this sounds like kind of like jokingly simple, but that's what we hope the technology, above the hood kind of covers and the use case it covers. And so what are some interesting goals? Like, what are we trying to achieve? What's the benefit of DSNs? And so integrity is really important, right? So today, I'm not sure everyone in this room or people who participate in, building software, when you use the cloud, how actually sure are you that data is stored well? Do you get to see inside of it? Do you even know what's like, do they give you like a receipt telling you, oh, it's in, this country and it's being stored on this hard drive? The chances are of that, they have no reason to, right? Because they're already making margin off you, et cetera. And so we, as an open decentralized storage network, as a version of that type of implementation, we want that stuff to be available to you. We want you to be able to check and see this stuff is stored well. Persistence is important too. So there's a lot of talk around other DSNs. There's a lot of other competitors in the space that store a lot less data. Talk about like this notion of permanence. So permanence is like forever, right? And they guarantee like, okay, I can store this data forever. Well, the internet's only been around for like 30 years. And I don't think like no one can prove that. But what we try to prove is persistence. So as long as you're able to, fund the storage of some data, let's say you're sequencing a rat genome for research, right? And you'll make that publicly available to everyone. As long as it's publicly funded, people put Filecoin to a Filecoin address, that data will be there. And you can price that out. So you can say, realistically, for 99 years, it will cost us $10 to store this data, which is great. Permanence is tough, though, because what if the network itself is flawed? And what if you are doing economics now where you can't foresee 20, 30 years down the road and your pricing model is completely wrong? And so we are much more invested in persistence because that lets us kind of evolve with the needs of the user and also understand kind of market dynamics as they happen. And I'll get into how we do this with Estuary later. The last bit is kind of like making sure that data is verifiable and auditable. So I think a world where anybody who uploads data, let's say data becomes a very valuable resource, more valuable than some precious commodities. We should be able to, as a society, verify that that data is stored well and it's accessible. So you should be able to retrieve it. You should be able to, run code against it that tell you where it's stored, et cetera. So I think this is really cool, and it can create a whole new market where there's businesses that help verify that this data is stored well too. So programmable data is a really fun topic. There's a lot of things that you can do that haven't been done today. So creative minds can really take advantage of this. To do this well, we also have this notion of content addressing. And I think to get into content addressing would be a whole nother conversation. Like we can spend a long time doing that. But when I showed you the Bored Ape earlier and I showed you that CID in the URL, that was a content address, which is using a hash, SHA-256, to store its data based on its content rather than its location. And so to give you a quick rundown, location would be like going to your browser and typing google.com, right? Who here can tell me where you go actually after google.com? What box are you taken to? You have no clue. Then you don't know how many boxes you're hopping. You don't know how secure the web page is when it's getting sent to you. right? With content addressing, you have this magic power, which is like, I can verify this content address, part of the whole verifiability, auditability of data, is a safe thing because it's the data itself. So I know there's no malware injected in there. I know there's no like secret backdoor that's going to track me. I can prove that this thing's what it is. And so very cool topic. We can get into that more later if you guys like. And so we want essentially what this picture kind of describes, which is, here is a CID, a content address. We can verify it's stored online. And then we can also verify that it's sealed. So you know which provider that is. So that's one data center that, is provided. I know it's a very small screenshot for people in this room, but I can show you guys more later. The success date, when it was stored, the receipt, so you know how long it's going to be stored for, and then, different methodologies for retrieving that data later if you want to. And we think all data should have this kind of function to at least be part of like a more open internet where you just know everything is, you can do whatever you want with this data. And so kind of like to try to build like a more modern UX around it, we click on a link and we get some data. So that's kind of like the dream vision, right? You have a CID, you have a URL, the content address, you can just pull it out. So
I have a question. So
yeah.
Let's say if I'm a data storage provider, and I have been doing this for like 2 years, there are a lot of data storage in my space, but now I have decided to change my life. I don't want to do this anymore. I want to. I probably don't have the space to store this data, or I just, I don't want to do this anymore.
Yeah.
So then in that case, like, is there a mechanism for the people who have stored data in my space to take the data back?
So this is a great question. So I think there's a lot of worry when you look at a system that is so distributed. What happens when people don't want to participate anymore?
Yeah.
So there's one mechanism we talked about earlier, which is collateral, right? So you put up so much money to participate in the network. If you were just to pull out, you'd lose that money. And the incentive is so against you that if you were to do that, it'd be very painful. But another thing that you can do is, as a storage provider, you can say, well, I want to store data for 6 months or 1 year at a time to really just test things out. And at the end of the 1 year, you can decide, I don't want to be part of this network anymore. And the storage providers can all do this. Everyone has that freedom of choice. What's nice about our system is that we replicate, because we're a distributed system where everyone shares the same code, to a whole bunch of storage providers, not just you. So you as a storage provider can decide one day you don't want to be part of it anymore, and it won't harm that data. It'll be replicated across other machines. So you don't run the risk of damaging the network. Now, if everyone in the whole world decided that they didn't want to be part of the Filecoin network anymore, we'd be in trouble. But the likelihood of that is very rare. And we build these tools and clients to kind of replicate things in a way so that, thinking of like fault tolerance, right? Where just because one actor doesn't want to do it anymore doesn't mean everyone gets affected. Because you're all kind of bounded by the same rules, the percentage chance that everyone pulls out is going to be very rare.
Yeah.
So that's our kind of a safeguard against it.
And then another question is that, as we just mentioned, data is crucial resources.
Yes, that's right.
So people can extract a lot of value from data. So let's say I'm a data storage provider and I have lots of data stored in my space, and then I want to monetize this data.
Yeah.
But this data don't actually belong to me. This is other people's data. But because they store it in my place, probably I have access to it.
Actually,
mining.
With public data, it's public domain. Okay. So there's, you're touching on a really good point, which is there's many forms of data storage, right? So there's encrypted data, which if they're storing on your machine, if they encrypt it themselves, you might not be able to access that and do whatever you want, right? But there's also like public data, right? That has no clear owner, but whoever's paying for it kind of gets announced to the network that I'm storing this data. And it's okay, it's a public domain. And this use case is actually really great, because if you have AI training sets, or you have medical research that you don't want to duplicate anymore, or you want to bring in like 20 institutions to do research on one thing instead of like having everyone do their own private case studies, right? This is a great way to have like a a network that you can use where everyone can just reference the same thing.
Mm-hmm.
When it comes to like, digital rights management and like ownership of data or like paywall data,
Mm-hmm.
this is where we are not the best choice,
Okay.
right? If you still want to be like, hey, I have some valuable data, no, you can't see it. So like in Cornell, I think they have a professor who has all the bird sounds in the world, right? And they want to charge like $14.99 for all the bird sounds. And they're like, okay, we don't want to change your business. You're probably better off using a centralized service because you want to gatekeep that data.
Yeah.
You want to say, unless you pay me $14.99 a month, you can't see this data.
Yeah.
But our network, I think, fits the category of if you have data that's available for everyone and you want to push progress for everybody, right? And it's extremely valuable, we're a really good choice. But you can also use us for the encrypted case as well. We have that. But I think it's, with CID, since they're all public and content addressed, it's better served that everyone can access that data for a public case. But the other case does exist. I think centralized services are still better for gatekeeping. There's a way to shut off access to everything else, So I think those cases will still exist, as I mentioned earlier.
So let's say if I'm a pharmaceutical company and the clinical trial data is basically the live goods. It's like such an important intellectual property. So in that case, I probably should use private.
That's a good argument. So I'll present a counter to that, which is what is more costly for the pharmaceutical company to waste their time for 3 years doing failed research, or to share that research publicly and maybe have access to other people's research publicly so that they fail less. This is a debate, right? So let's say you have venture capital or you have money to do experiments for 4 years, but none of those experiments bear fruit. And you didn't know as a pharmaceutical company that other companies are doing the exact same research and failing the exact same way. In some ways, it's better to know those things were failing so that you don't do it too. So I think they'll cut a balance. They'll say, okay, we're doing preliminary research and this stuff is failing. They'll share that out. Other companies will be like, wow, like, thank you. They can maybe use a native token to like say, okay, we're paying the network, or this is maybe it's like a data NFT, right? So like I pay you for this NFT access, at least to share that. And I think they'll strike a balance somewhere in the middle, because I think at our hearts, we all want to solve some very big problems in those spaces, right? Like imagine if everyone worked together in coordination, we could solve Alzheimer's faster, which would personally be amazing to a lot of us, right? They have to take a step back and think, well, gosh, how important is my profit or gatekeeping the solution compared to a collaborative effort that's global, right? And so you have country lines, you have, nation lines, everything, continent lines, whatever. I think sometimes thinking bigger and being like, okay, let's do some public good for part of the research and do some private bits as well, and do a hybrid approach to kind of be the better solution. But I can't speak for pharmaceuticals. I think there's a variety of them that will want to gatekeep in the current model because they have to return some capital or else they're done for, right? But I can imagine a world where, just like open source development is so incredible now because you can fix bugs and contribute to a stack that you love to use without needing to get paid. In fact, the fact that your favorite tool is being fixed by the community, you just like the fact that the tool exists and helps people, right? And so there's a lot of people doing that. And some of the open source code gets used in very proprietary production-based systems. That's why we have exploits sometimes that are pretty scary, but it's also like not done because of profit, or maybe it's indirectly like second, third, fourth degree hopped profit. So I imagine the same for research. In fact, I think this topic is really cool because maybe we need to open up research more and share that data more openly so that people can level up first before thinking about profit. What if every university is behind the times and needs to catch up? So, there's a lot of ways to spin that, although I think that case definitely does exist. Profit is definitely very important for pharmaceuticals.
Interesting. Thank you.
Great question. So storage landscape, I kind of want to touch on this because we were kind of getting to that topic. Our engineering team, we have a product called storage.market. It's a really simple website. We've indexed around 4,800 storage providers, but I think the number is closer to 7,000 plus in the world that are backing our storage network. We only work with 800 of them because we give a lot of storage providers different control for what data they take. So we want to provide maximum flexibility. So it means that some storage providers don't need to take new data. They can just stop at a certain point. And hypothetically, each storage provider can become its own business. So if you think about these individual nodes, they have all this data. they can build their entire own set of apps. They can build their own TikTok even if they wanted to. And I think that's really cool when you kind of provide that kind of flexibility to everyone who participates in the network. It's like, there's no limitation. Build your own APIs, build your own post-processing data. If someone is storing cornfield data on your data center, you can circle that for people and do a whole business where you circle all the, like farmed fields, or you circle all the, like let's say you're taking photos of cities and you want to circle all the crime that's happening in cities, you can totally do that as well. And so there's a lot of business opportunities. And in the market right now, storage is actually a really big deal. I'm hoping more people in college kind of see this. We have AWS, Azure, GCS, IBM Cloud, Sync, Carbonite, Dropbox, Iron Mountain, OneHub, iDrive, Nextcloud, list goes on. Karine on our team has been killing it, pretty much found everything, the whole storage market for us. So all of this research is thanks to her. And then the new emerging Web3 entities like Estuary, Filecoin, Storage, Subspace, Skynet, Skydrop, Swarm, the list goes on, Arweave, Sia, Lighthouse. I like that question. I'm going to get into that. So estimates data centers worldwide is 600 exabytes of actual data. I got this from a site called Statistica, but if you guys might have access to better data, please let me know. I can be wrong, but I think this is a pretty good estimate. I'm also very, very confident we don't know how to use this data. So I'm very confident there's data at this scale, 600 exabytes, but very few people know how to wield it. In fact, if you know anyone, please intro me. I'd love to meet them. And so let's talk about maybe some other storage networks. There's Arweave and proof of access. So Arweave is a very popular storage network. It has, at most, I don't think they've passed 100 terabytes. So it's still kind of a very small network that's used for very small files. But they have this kind of variant of proof of work where they check that new transactions have a randomly selected marker from the earlier bundle. And if that marker is present, more data can put on chain. No individual piece of data can be more than 3 megabytes, but they have people building services on top of that to make it scale more. I'm very excited to see how they kind of get to the next 100 terabytes beyond this. But I think proof of work and on-chain storage is really troublesome because consensus is very hard. So as I talked about earlier, building consensus between machines is not a trivial matter. You need to invent new ways like snarks to improve the rate of calculation of proofs. And I think Arweave is doing an interesting model. I know they have some new stuff coming out, but I'm looking forward to seeing that stuff and kind of analyzing their network. Storage is like one of my favorite centralized storage solutions. They're not as decentralized as I think our network is, but they have really great engineering and they're really well thought out. They do a proof of retrievability. And so to spare you a bunch of details, I'm sure you can read this, but the proof that the data can be retrieved is a great way to prove that the data is stored well. And they use a token as a reward mechanism for storage providers. And so, but they also don't completely couple everything together in a way that requires on like this purest form of centralization. So they're able to get some optimizations from like co-opting some cloud-based technologies as well. And so I think it's a thing to watch. They're kind of like in a lot of ways similar to Filecoin, but they have less of a need for consensus-based driven technology because they have some more centralized bits. And so, yeah, proof of retrievability is a great way to like build a simple DSM. And so what? While total storage capacity in the world is increasing and there are more novel attempts to take advantage of the 600 exabytes, there are some very big problems. And so looking at all of those companies, looking at all the Web3 companies, and looking at where we are with all of our participants in the Filecoin network, we don't have a privacy advantage. So we had a great conversation just a second ago about, like what if a pharmaceutical company wants to have private data on chain? And we don't have that advantage. If you're on a public network, someone one day is going to break your encryption. I think it takes about 10 minutes for any password today. So if someone were to get a database and see a hashed password, they'll crack it in 10 minutes if they have access to the resources, right? So using encryption is not the safest thing. Now you can do cool things. You can shard that. You can break your password up into little small bits. You can have an index where you stitch things back together, and then you don't tell anyone about this index. But then that index is centralized. You have a centralized component now to your system. So it's not pure, right? So the privacy advantage is hard, but for public data, we're still really great. The other thing is like, if you're Azure, GCP, or AWS, you probably can guarantee a baseline of the hardware that people are using for your DSN. We can't. So what that means is because we're an open source network, anyone can come in and connect to us. That means you could be running it from your basement. You could be running it in a country that has low bandwidth, right? And we don't have any control over that, but we think that's a good thing because we want to lift everything up together and we want to set some benchmarks so that you should encourage yourself to run code. But if you want to just provide storage, you can. We think of that as kind of a principle of being open, right? But it's a disadvantage too, because if you're a cloud provider, you can be like, oh, we're all SSDs or NVMEs, right? We're like this very like well-designed data center, and you can guarantee that for every data center, right? We would love to be in that situation, but openness means everyone can kind of participate. And I mentioned this earlier, as of today, no one has shown me how to view an exabyte of data within the browser. And so Estuary, our tool, we stored close to 10 billion objects, and that's only 1 petabyte. So I'm waiting for the day that someone can show me how to view an exabyte of data. I think this is actually a really fun challenge if you're into graphics or you're into like, building apps. Don't just build the social media app or the photo viewing app. Find me a way to see a billion objects in the browser, and I will reward you. If you can do this, please talk to me. So there's a whole bunch of problems. And I know I've been a little bit all over the place, but we built a platform to kind of address some of these problems for Filecoin. So Filecoin's a layer 1 network, and the network doesn't need to do everything, right? We can build applications and network nodes and validator nodes that make sure that things are going well in the network. So we built this tool called Estuary. And Estuary is what we're demoing today to show you how easy it is to get data to Filecoin and etc. And so I'm going to play this video and take a talking break because I've been talking a lot. I like the latency. It feels really, this is kind of a visual what we're building. So you have storage providers around the world, and Estuary sends data to all of them. So instead of interacting with storage provider directly, we built a service to kind of act as like your airdrop of data, right? So let's say you have 31 gigs of something, we can bring it over. And I'll cut this video because it's a little laggy on the screen. And I want to give a shout out to the Protocol Labs engineering teams, Entra specifically. They made a lot of the stack that we use. What's really cool about this is that it's all open source. So we do not hide our trade secrets. Dig in. If you want to see how everything comes together, it's all there. And my engineering team will happily walk you through nearly everything, whatever you want to use. And so I want to give a huge thanks to everyone in Lisbon. If you're tuning in or not, thank you so much for building all this stuff. To date, when people say that who's using DSNs, right? Like why is there any usage, right? We've got 8 billion objects, over 100 million root CID stored on Filecoin, over 100,000 storage deals, 200 plus terabytes of pinned data. If you look at most web services, they don't even cross like 500 gigabytes of data. You imagine like image files, for any service are like 5 kilobytes, maybe a megabyte, 5 megabytes. So that number is huge. And then we replicate that data across all the storage providers, and we get to about a petabyte total onboard data, which is really hard to do. Our incumbents, like Meta, they do 3 petabytes a day, but that's because they serve 4 billion plus users, right? So for a small network, what we are compared to them, we're actually doing great in these 2 years. And then 524 accounts, I add that because it's just a whole bunch of companies where we don't track them, we don't know what they're doing, but that includes Mirror, Zora, ChainSafe, a whole bunch of cool Web3 tools. And what you get when you use our tool is kind of the verification story. So you have every single storage provider, and you can look into each one, and you can see proof of where your data is stored. So if you really want to know everything holistically about the data you're storing, you can click in, see a receipt, and you know everything. And you know how to get the data back whenever you want. There's 2 ways this can go. Either the cloud copies us, I think, which is like providing the same kind of solution through AWS, or this is the way that we can continue to provide value that the cloud cannot, and we keep making this more mainstream. I think all data in the world, you should be able to track its lineage, you should know where it's stored, you should be able to do whatever you want with it. That will advance a lot of things. And so here's a cool product UI if you guys care about that. Our code for how we store data, this is what I would love out of every library in the world, any proprietary software, so be as transparent as we are. We have all our functions labeled. Every line, you can go into GitHub and see everything in detail. So no secrets. This is how you should build a open source decentralized tool, right? For people who want to store data. And, an example of a deal proposal. So kind of being able to learn how the network works through being able to see different parameters that make a storage deal as well, help teach people like programmers, how to use a network too. So instead of having to kind of like go blindly into developer tools, we have documentation and different bits that you can look at. And so this bit right here, this little outline is available open source just like this. And if you can read code, you can kind of navigate everything. And so we wanted to make uploading data to Filecoin a lot easier. There's other services like Web3 storage and NFT storage who are really well built. So shout out to them. And I think I've outlined the goals pretty well. We want anyone in the world to store data. We want anyone in the world to retrieve data. Anyone can program automation around storage and retrieval. Storage can become a tradable commodity, tradable in open markets, and then storing data as a human right. So everyone gets access to what I said in the beginning of the presentation, just put and get. And, we build out examples of automation that people can use. So this is a very silly diagram, but as simple as we want things to be, Filecoin goes in, data comes out, and building automation tools around that. And so if we prove this model out well, and we do better on content delivery, I think the transition for us, the real victory state is when services that are mainstream like YouTube or TikTok and all that data that's public anyway, right? So if you create a TikTok video today, that's a public video. You should be storing that on a public network, right? That way, you can take advantage of the cost savings. And so we did some analysis before. I don't want to use the wrong numbers, but there are massive savings, maybe 8-digit savings for all of these public companies like Snapchat or TikTok, if they were to switch to public networks too. So we don't have to make it a blockchain thing. IPFS is not a blockchain, right? So when you store us, we can keep that cached for everyone to retrieve. And then if a user wants to back that up permanently, they have a choice. So providing that flexibility is really cool. So I think, we're getting to that point where we're starting to see real utility. I'm happy to look back at this in 5-10 years and see how that goes. More bits of how we work. To your point earlier, we store 6 storage providers. So, if you decide, if you're one of those providers, you don't want to work on this anymore, you go down, we instantly put that data back with another provider. So our tool allows for this kind of making sure the replication standards are met for the user. So you could be someone who's like, this genome data must be replicated 5 or 10 times, right? And the network will have a lot of variable chaos. So people will drop off left and right. Maybe they had a bad hardware setup, they can't keep going, but we're watching that all the time. The moment it happens, we fix that and we get the data onto another storage provider. So that's something that our tool does. That's really cool. And you can run your own. So we give instructions. So at the end of this talk, if you want to learn how to run your own, you totally can. We have an engineering team of 15 plus now. So if you want free bug fixes or you want things to be improved, you can follow along with us, and every improvement we make, you get it for free. We have a GUI. So I'll demonstrate that GUI later so you can use it and upload data and kind of test it out. We also we run one ourselves, so you can see how it's run. And you get a managed Filecoin address as well. So we're adding features there where, you get a Filecoin address, you're a real participant in decentralized storage network. So it's not like just centralized. You get to actually manage your account, store data, and, be part of this network. And, a template to build your own products. So we have cool products like Slate, Portrait, etc. And so an example of what you can build on top of our node, here's an example of Filecoin wallet. Here are some companies that are using us since April 2021. I want to thank everyone here. It's been super cool to be building in the open with all you guys. And, you dealt with all our bugs, but I don't know if anyone is here from these companies today, but thank you for working with us since 2021. And I'll give a demo. So I'm not going to demo this view because you can all try it if you get an Estuary invite. But we wanted uploading data to be as simple as drag and drop to the Filecoin network. So I described all the complexity of a DSN earlier, the putting and getting, and you could imagine like, wow, like how do I use it? We want a tool that makes it really easy just to upload data like Mega Upload or Amazon S3. So we demonstrated that here. And then you can see all the success for uploading that data. And then you have all the verification and data integrity and auditability that we want. And then we have documentation right here. So I'm actually going to go into my browser now and stop showing this. And so I have an account on Estuary, and I'm just going to demonstrate uploading data. So here's me adding a file of the presentation you just saw. I'm going to upload that data. And this is the UBC internet speed. So we'll see how that goes. 145 megabytes, but hopefully it's the challenge of doing things.
Yeah, so as this part is being maybe I can ask a question.
Yeah.
So I can see that this is kind of like a direct competitor of Dropbox, for example, Google Drive.
Yeah, yeah. Sure.
This is like a decentralized Dropbox or decentralized.
And there will be many of them.
Mhm.
We expected there to be hundreds.
Yeah. So so from a user's perspective, let's say I'm just a very average person that sometimes would need store my file somewhere online. And I'm now using Google Drive and using Dropbox, and I have all the accounts linked, and I've been doing that for 3 years. I'm very used to it. So how can you convince them to transition from those traditional methods to your platform?
Yeah, on the pace layering curve, right? Trying to predict fashion trends and application usage trends are very hard, right? And there are miracles like TikTok and Snapchat that constantly have month-over-month growth that's really exceptional. And those are the people that, when we're infrastructure builders, we have to prove to those people who build those applications, those designers, that we have stable infrastructure that works really well. And that battle, I think, is very separate. So consumer productivity, cognitive applications, that space is nebulous. Here at UBC, you may do work differently than someone in Stanford and someone in University of Boston or MIT. And the culturalism involved there is very tough to deterministically approach. So someone might use a different language altogether. Even some schools are different language houses, right? Some schools write Java, some schools write Rust now, And so I think what we can do and what our strategy has been is provide the most reliable infrastructure for decentralized storage networks and support Filecoin mostly, but other networks can learn from us too. And then we're hoping to invite application developers who are building Dropboxes, who are building boxes to use our stack and at a cost advantage. So people talk about this term called product market fit. I think there's also product market price fit as well, right? So as a developer, if you're going to want to compete with, or we know that we're sitting next to GCS, S3, Azure Storage, right? We know what they're priced at. We can tell developers hey, we're providing this infrastructure has new function. So that means new benefit, but also at a competitive price. And we hope that the amount of people we support out of that will come out with a tool that will produce someone who makes a Dropbox paper competitor, right? Or and through that, that's how we win. So Estuary, for example, is even the web product itself is open source. And I think what that leads to is if you're an application builder and you think you can do a better UI than Box, you have all the tools that would normally cost you maybe 2 or 3 engineers priced at 150K, 160K a year to work with you on. Now that a lot of that work's done for you. And we're hoping to help accelerate that curve for the number of apps that compete with Box. So it's kind of a dodgy answer to your question. How do we compete with Box? It's necessarily I build a better app. It's I introduce 1,000 competitors to Box instead. And then maybe, they go and they're okay, Box has to deal with, people making innovation across the board in different cultures, right? So part of the best thing about DSN is that it's globally distributed. So we're going to have advancements in Japan, China, Korea, Australia, India, Sri Lanka, Germany, France, and Box will have to compete with global trends, not just us, and while keeping their existing user base. So we kind of have this advantage. And also our underlying incentive layer is not from owning the centralized consumer pipeline or funnel. Our advantage is because, wow, this thing takes a long time. Our advantage is that our incentives are already in the crypto economics. So, we just want people to make more tools. And I would say that it's nice that as an application developer, you can build tools on open infrastructure that you kind of take back ownership of your tools. So there's a whole offline software movement as well. There's a whole bunch of different ways to look at software. Like, do we need to be connected all the time? And when you have a DSN that's available by the consensus of these nodes, you can plug in when you want to and unplug when you want to. You know, cloud stuff might not allow you to do that. They might be like, you must get my data through the centralized, you know, non-fault tolerant points. And if you don't, there's no point in using us, but we're the cheapest, right? That's kind of like a really tough way to treat a developer. A developer should have optionality and control over their data and like a good sense of the integrity of that data. So that's my long answer.
Okay.
To
Interesting.
yeah.
I think the built-in crypto economics part is very attractive to a lot of average people.
Yeah, I think so. I think most people are going to be very considerate of price because not everyone has the budget to burn $250K a month on expensive storage, right? If you're a genomics professor and you're trying to sequence the whole human genome, the cost of the data center could be huge. It could become $1 million research project, right? And so giving, you know, a public resource that can be cost advantage for those kind of things, I think will help compete with some existing incumbent. And then from there, you know, who knows, right? Like if I had a crystal ball, I would use it more often. But, you know, so I'm going to actually open our tab here and demonstrate the API key upload. So we have API keys, my current browser session. You can create a key. I just want to show you guys how easy it is to use our documentation. So we have our docs, and I made a live coding environment, so you can just delete stuff and things will break. But you can code here, and we provide you the curl command, so you can use the curl command. And actually, I'm just going to open up my command line. Sorry, everyone, I used a new laptop today, so it's been a learning curve for me. And you can use the command line. I'm not logged into anything. So we wanted to make, I think one of the cool parts of centralized storage networks, I can design an API that's much more friendly. Now, the second bit of this is with this API key, if I want to upload data to Filecoin, we want to be as easy as going into the code, replacing this like that, and then choose file. Oh, come on. Well, we want it as easy as choosing a file, and you can upload a file right from the spot. So I think, you know, for some reason it's not.
So it seems that there are some questions in the chat.
Yeah, you can email me at, well, how about we do this where I don't publicly say my email, and then you can, you can share it with attendees later on.
Sure. Hi. So I think this question is from Louis. So if you would like to have Jimmy's contact information, please send me an email, and then I will connect you with him. So this is my email address.
Nice.
So any questions from the online audience and also from the room? There's a question to me.
I'm really interested about the benchmark of your, for example, Filecoin, about latency and how long it takes to upload the file, because as an application developer, it would be really important for example, how long it takes for a user to upload the video.
Absolutely.
So I want to see how it looks in compared to, for example,
So I just did a live example of it. I'm on the visitor network of UBC. I don't know if I'm throttled, but I just tried to put 150 megabytes on, and it took a while. We had a couple times for like some questions. It's unacceptable for your use case, because so we're done now. The data is there, and you can retrieve it from the CID that's here. Good timing for your question. And then I demoed this from the hotel I was at, and I did it within 10 seconds. I was able to get the whole file back. So I was very excited about this before I presented.
The visitor network is real slow.
The visitor network is real slow. So using this link now, I should be able to get it back. And this is this is now being replicated across this DSN, across 6 storage nodes and everything. And so latency and performance are so crucial to applications. That's user experience, right? You're so right. And that's our disadvantage right now. Because with a centralized node, you have one coordinator that can kind of dictate where resources should be used and optimize individual parts. Not to say DSN can't do that, but we care a lot about consensus and proving that you're storing that data and doing it trustless, right? So every node knows. So we're not there yet where we can compete on latency. But if you go to OpenSea, you go to like a whole bunch of networks that have assets, there are ways. And I think we might not be at the 10 milliseconds that you want, but 30, 40 is okay for now. And we are making improvements because the infrastructure is much more like predictable and reliable and doesn't require human management. So everyone trusts the same code. So you're basically making a bet on, well, this new technology, this car does not move as fast as a horse. Is it the car bad then? I don't know. Cars are bad for the environment. It remains to be seen if we should have been making cars in general or horses were the right way. But horses, were faster than cars for a very long time until we had some breakthroughs. And you have to look at where the innovation is. Can we biologically modify a horse? Maybe that's a bad comparison for the cloud, but they seem stuck in their ways. Versus I think DSNs, we're still innovating. It's still early. Filecoin's only been out for 2 years. Research for IPFS only been 8. Implementation maybe 6. So give us another decade. We'll see.
All right, so I see that we are on top of the hour. So let us thank Jimmy again for the wonderful presentation. I think I learned a lot, and I'm sure all of you also learned a lot. And so for those who are in the room, please feel free to stay a little bit longer. So we have reserved the room until 1:30.
Nice.
So if you have any more questions, you can still ask Jimmy. And for those of you who are online, if you want to ask Jimmy questions, please send me an email and then I will connect you with him. Okay. So on that note, thank you, Jimmy. And I wish you a wonderful week in Vancouver.
Thank you.
Yeah, thank you.
Happy to be here. Cheers.
Cheers. Bye-bye. Bye-bye, everyone online.